All right, today class we are going to be talking about the volume of rectangular prisms and triangular prisms in this particular video. Okay, so we know that the volume is going to be basically the space that a 3D figure will actually take up. We're going to look at several examples, and then in the next video we're going to explore the relationship between a rectangular or triangular prism with a corresponding rectangular pyramid or triangular pyramid with congruent base and the same height. But for the purposes of this video, we're going to focus on, as I said, the volume of a prism. So if we notice there, the formula for a volume, for a prism, the volume is going to be the area of its base, also known as big B, times its height. So again, that formula says V is equal to big B times H. Now it's going to be super important that you know the difference between big B and little b. If we think about a triangle, okay, in the shape of a triangle, we know that the bottom portion of a triangle, if it's right side up, quote unquote right side up, that's going to be the base of that triangle. That's little b. However, big B would be where I would figure out the entire area of the base of a 3D figure. Okay, so let's go ahead and start exploring. The next screen that you will see will be for our first example. So this particular technique that we're focusing on primarily 7.9a, but we are going to be focusing on 7.8a a little bit. I'll just sort of mention it in this video, and then the one that is actually labeled 7.8a and 7.9a, that's going to be where we recognize the relationship between a pyramid and a prism. All right. So if we look at this particular prism, we know that this area here at the bottom, okay, is going to be the base. That will be the surface. So for example, if this were, say, a tissue box, and this was sitting on a table, this is going to be the area that touches the table and the bottom of your box. We know also that the parallel plane, or the area, this area here, is going to be parallel to this base here. So these two are going to be considered our base. Now, for surface area, that's going to be super important that we realize, again, that those two are bases. For our purposes, again, our volume is going to be where we find the area of this base and then follow the formula to actually figure out the volume. Okay, as always, we need to go ahead and start with our formula. That formula, again, is going to be V, big V. V is Victor, is equal to big B, that's boy, times the height. Okay, so we see here that we have a height of 7 here. That's the height of the prism. We can, again, go and interchange this. We'll just say that this is our length, this is our width. Of course, we know that we can transpose those, swap them, because 12 times 15 is going to be the same as 15 times 12. You just have to be consistent with your calculation. So let's go ahead and switch over to our drawings page. All right, so for the first one, I know that, as I said, my height of that figure, we are going to say is 7. That was 7 millimeters. We know that the length, as I said, or the little b of that base was going to be 12. And then the height of the base shape. Now remember, your base shape in this case was going to be a rectangle. We are identifying little b or L, whichever. Remember, this can correspond with L, being that we're in middle school now. We're not going to refer to this as L. We're going to refer to this as B. We know that the height of that base is also corresponding to W, length times width, or base times height. Same thing. Okay? I know that this is 15 millimeters. Now remember, it is super important that you go and lay out all of your dimensions, so you're not having to keep going back and forth to the shape over and over. So the volume. Again, I'm going to set this up as, and I'm going to leave my my unit of measure behind for just a moment. I know that this is 12 times 15 times 7. Okay. We're going to set this up through the magic of YouTube. I already know that 12 times 15 is going to be 180. I'm going to multiply that by 7. That's going to give me 1,216. Okay. I'm going to go ahead and reattach my unit at this point. I know that it's now going to be millimeters cubed. We know that our our unit of measure for volume, when dealing with volume, is going to be some unit cubed. Some unit cubed. In this case, I'm taking, this was 12 millimeters, multiplying it by 15 millimeters, multiplying it by 7 millimeters. When I multiply the same unit 3 times, it's going to be some unit cubed, in this case, 1,260 millimeters cubed. So that is the amount of space that that rectangular prism will occupy. Okay? I'm going to go back over to our next example. This was for a rectangular prism. Okay? Now, let's go ahead and go over to our next figure. Now, in this particular case, we are not given a picture. So it is incumbent or very important that we actually go ahead and draw something to correspond. First of all, let's go ahead and read the problem. It says that we're going to use that formula that we've already used in the previous problem. V is equal to big B times H to find the volume of a gift box that is 3.5 inches high, 7 inches long, and 6 inches wide. Now we're going to use our powers of visualization like we did for the first time in elementary school to figure out what this is going to look like. It says that a gift box, we've all received a gift before, we all know what they look like. The traditional gift box is going to be a rectangular prism. So I'm going to switch over to my drawings page again. What I'm going to do is I'm going to go ahead and draw myself a picture. Okay, so never proclaim to be an artist, but I'm going to do my best job. Okay, looks like this is coming out okay so far. That looks like a gift box to me. Okay, not perfect, but it will do. Okay, 6 inches, 7 inches, and then I know that this dimension here, the height of the box was 3.5 inches. Okay, now I'm going to highlight, I'm going to color in, I should say, where my base was. Okay, now if you notice in the problem, they use the terms length and width. Being middle schoolers, we're now going to realize that length and width is corresponding to base times height, because remember that is what our formula says. Big V is equal to big B times H. Big B in this case will be where I'm going to take my, and we'll switch back over really quickly. It said that 6 inches long, 6 inches wide, 7 inches long. Okay, so we know that this was our length, this was our width. Going back again, yes, I have that correct. All right, so big B times H, we're going to say that L is going to correspond to B, W is going to correspond to H. So in this case, I'm going to multiply 7 times 6 times 3.5. I've left my units behind for now. Let's go ahead and pull up a calculator. Now, in our calculator, what I'm going to do, because we're dealing with decimals at this point, I don't want to actually make a mistake. I'm pulling up a calculator because this is something that you're going to do by hand, but for the purposes of making sure that we are accurate. And those of you that are studying 7th grade curriculum at this point will not have access to a calculator until next year, but I'm going to pull it up to make sure that I'm correct. 7 times 6, 7 times 6 times 3.5. I'm going to hit this button, that's our equal sign. We have 147, so if I skip back over to my drawings page, we have 147. Now remember, our unit for volume is always going to be in units cubed. In this case, it was inches. So again, inches cubed. Okay? Cubic inches. Simple enough, right? Now, let's go ahead and go over to something that we maybe haven't dealt with a whole lot. And this is going to be a triangular prism. Now, remember, as I said earlier, this base must be parallel with this base here at the top for that to be considered our base. Now, when you look at a triangular prism, that one is going to be a little tricky. So let's go ahead and identify what we have. I'm going to switch back over to our drawings page. Now, here on our drawings page, we know that the Prism formula is still going to be big B times H is equal to your volume. Now, which of these is a base though? Now, I know that if I were looking at this side that is going to be your rectangle, is that a base? Is there any side, another side that is parallel to this 8 by 7 piece? We know that these two over here, these two sides okay, are they parallel to this particular side? Probably not, okay, or they are not. This side here that is 5 by 7, this rectangle over here, or is this rectangle over here, is that parallel to another side? No. So what are the only two sides that are parallel? Now, one clue is that the name of this prism is called a triangular prism. Normally, that first part, the descriptor or the adjective that describes that prism is going to tell you which one is the base. In this case, a triangular prism will have bases that are, you guessed it, triangles. Okay, so this is our triangle. It's bordered right here. Okay, that's our triangle. So the height of this triangle is going to be 3. That's where this line is pointing. And the base of this triangle, that little b, is going to be 8. Okay, so let's see what that looks like. If we go back to our drawings page, all right, so we know that the base, big B, was a triangle. And the dimensions of that triangle were, for the base, it was going to be 8, and that was feet. The height of that triangle was 3 feet. Okay, that's for little b. And then the height of the overall prism, okay, and I'll switch back over so you can see that. Okay, the height for that prism was 7 feet. Okay, so base here, base at the top. We know that these two are parallel, so those are our bases. This is the overall height of the prism. Okay, so now, if I plug this in, I know that 8 times 3, because we know that our formula for the area of a triangle is 1/2 little b times h. I'm going to multiply this by that. I'm then going to multiply this by 7. I'm leaving my unit behind for now. Okay, so again, if I keep simplifying this, this is 24 times 1/2 times 7. 24 times 1/2 will give me 12 times 7, which will ultimately give me 84. Now, this is 84 feet cubed. 84 feet cubed. So, at this point, I've given you 2 different examples of a rectangular prism and 1 example of a triangular prism, and that's pretty much it for this video. So again, if you have any additional questions, what I want you to do is I want you to go ahead and go back over this video, okay? What you may do is wait till you're in class to actually ask me a video during one of our check-ins, or you may come to a tutorial session during our normal time frames. And as always, I will see you guys soon.